was growing up there, and it is today. It also is one of the counties that has produced the most coal. I don't know if y'all are familiar with Central Appalachia and the fact that we get most of our coal from there, but for the longest time, the country was getting the majority of its energy from burning coal, and so West Virginia was really important. What happened, though, is the coal industry kind of dried up, and the place became pretty impoverished. And so that was about the time when I was growing up. And we didn't produce a whole lot of scientists, I would say. But when I was in elementary school, I pretty much went from wanting to be a paleontologist to then wanting to be a firefighter. And then I decided I wanted to be an astronomer. And here I am today, an astronomer, some number. I'm not going to do the math in my years. But the way I got interested was, I think they may still do this now, that we used to have these book fairs, and people would come and they'd set out all these books, and students would go around and you'd buy a few books. And one of the books I really wanted was an astronomy book whose title was What's Up There. And I didn't get to it in time. One of my classmates got the book, but he eventually let me borrow it, and I actually still have it. So he gave it to me on long-term loan, and it completely sparked my interest. And I read that book over and over and over again, and decided that that's what I was going to be when I grew up, was an astronomer, an astrophysicist. And I was going to go to big telescopes in Hawaii, and I was going to observe the stars and stuff like that. And I tell you, growing up where I grew up, when I would tell grown-ups what I wanted to be, they would kind of look at me funny, like I had a third eye on my forehead or something like that.
Like you were an alien?
Yeah, like I was a bit of an alien. But you know, I didn't know this when I was a kid, but I grew up in the county that Homer Hickam is from, the guy who launched the rockets in Coalwood. October Sky is the movie that they made about his memoir. So there is a little bit of a history of growing up in that region and somehow getting an interest in space and stars.
So you to go from rural Appalachia and continue to aspire to be an astronomer and go through college and end up at Colgate University, who are some of the significant mentors that you had, and what are some of the essential skills they taught you to be successful?
Well, so I had a father for a science teacher, right? He was a science teacher in a local middle school. And so when I started to kind of show an interest in science, he really took to that. It's so much so that when Halley's Comet came by in 1985, 86, he organized big events at our middle school. And I happened to be in middle school at the time, so I was benefiting from these events that he was organizing. So there were little things like that along the way that he was always doing to encourage my interest and support me. So that was really valuable, having a mentor like that at home. In addition, I had some really good teachers, not always necessarily science teachers, but I had some really good teachers all the way through, from elementary through junior high and high school, who supported me, who made me feel confident in my abilities, who made me feel like I could do anything I wanted to do, if I put my mind to it. And that's really valuable. So when I left McDowell County, I went off to college at a small liberal arts school in Virginia, knowing that I wanted to pursue astronomy. They didn't really have an astronomy program, so I studied a whole lot of physics and a whole lot of mathematics, and had a few mentors there, but I didn't really reach out to people like I should have. And so if there's one piece of advice I could give, is like, you need to make these connections with people and develop relationships with folks who might be your mentors and will help you along the way, because it's unreasonable to expect that you just do all this on your own. And so I left, I got my undergraduate degree, and I ended up at Vanderbilt in the PhD program, and started studying astronomy there. Did more physics in terms of coursework, but my research was all astro focused. I got my PhD. I loved Nashville, loved Vanderbilt, but had to leave, and then went to the University of Virginia for a postdoc for a few years, and then moved into this appointment as a professor at Colgate right after that.
Okay, so lots of studying, but I think one of the things that we can also our students can take away, and you don't have to wait till college to go make those relationships. Certainly engage with your teachers, ask for extra help, in spite of COVID, when we get back to some form of normalcy, really take the extra time and spend some time with your teachers, because they're awesome mentors as well. You know, through those experiences, you've been quite a mentor at Colgate, done some really cool stuff with your students. Can you share those experiences? And, you've traveled the country and taken students with you. You cook with your students?
Yeah, yeah. So I do a lot of things with students, because I'm just not in the classroom with them, or I'm just not advising their research projects. I'm now directing a residential commons, which gets me into their living spaces and has me doing things in the residence halls across campus. And so for me, it's always an opportunity to one, for me to learn something from them, but for me to also teach something to them and hopefully make them more curious about the world. In terms of being an astrophysicist and a mentor to these students, I've taken students to Hawaii to observe with the telescopes on Mauna Kea. I've taken students out to the Southwest, to Arizona, to Kitt Peak, which is a big national observatory with big telescopes. We go to New Mexico. I even got to take a student to Germany one time with me to do some research with collaborators I had in Germany. So it is, it's a privilege to have a job like this that allows me to do stuff and pursue my own interests, much less be able to share those interests with students.
Okay, so what are some of the most exciting discoveries happening in astronomy at this point in time? In our last session, you said in 1995 they discovered other planets that, revolved around other stars. Where is the exciting world of astronomy headed, and what should our students be looking for and researching if this is a pathway they want to pursue?
Yeah, so we still are really interested in these planets, and that intersects with my own research. But we're also interested in the earliest moments of the formation of the universe, right? And so I think these two things, that what we would call cosmology, which is kind of the study of the universe as a whole, and then the study of the formation and evolution of these planets, some of which may be very much like the Earth, I think are two of the most interesting, in my mind, two of the most interesting avenues of research. And I tell you what, let me show you some. I'll show you a couple slides that I put together. And this is just a picture of my hometown. I wasn't sure if I was going to show that, but this is my hometown, Welch. As you can see, it's kind of like tucked in between these mountains. And off to the left there is a railroad that used to carry coal cars, or cars full of coal in them. Can you all see this? Because you all have now disappeared for me.
Yeah.
Yes, we can see it.
This is an artist's conception of a stellar system that I study in a collaboration with a bunch of mostly French astronomers. And there are two of us from the U.S., but I have a bunch of collaborators over in Bordeaux in France. This is a star that's about 500 light years away from us. So if you were riding a beam of light, it would take you about 500 years to get there. And some of you may have already learned that light travels really pretty fast. What you're seeing here in the center is one star that has some material around it, and then these two stars over here. So it's actually a three-star system. And then you see this ring of material around them. And what we've recently discovered in this system, which is really interesting and is related to this whole question of planets, and this is like sciencey. This is from this is still a picture of that system, but what you need to pay attention to is just like the colors. This little blob over here, which you may be like, well, that just looks like a little blob. That blob is denoting a hot spot in this ring, right? And that hot spot could be really significant because this is a really young star system. It could be that this blob is a planet that we are seeing that is caught in the midst of forming. And so we're making preparations to go back and look at this system again and study that little blob in more detail using the James Webb Space Telescope, which is about to be launched this coming year. And so we're going to go and probe that more and see if we can confirm that it really is a planet that we're catching, that we're seeing right in the midst of forming.
Wow, that's pretty exciting. So, I know there's some students on that were on last time, but there's a lot of new students. In our last session, you talked about planets similar, like giant Earths, similar to Earth, but you refer to them as giant Earths. Can you share with our students, what that is?
Yeah, so we've discovered thousands of planets now. And the statistics, discovered so many planets that it seems to indicate that most stars in the sky actually have at least one planet orbiting them. Some fraction of those planets are going to be Earth-like. But in the process of detecting all of those thousands of planets, we've detected a new class of planets, a type of planet that we don't see in our own solar system. And those have come to be known as super Earths because they typically are 2 or 3 times the mass of the Earth. And we don't have anything similar, what we would refer to as an analog. We don't have anything similar to that in our own solar system. And so we've discovered a new type of planet. Now, for us, if we were on a planet like that, the gravity's probably a whole lot stronger, so we might not even be able to walk on a super Earth. But there are other planets out there that we have detected that are the size of the Earth, that have the mass of the Earth, that we're trying to figure out what their atmospheres may be like if they happen to have atmospheres.
So there's a high probability that some of these super Earths or other planets would have similar characteristics and chemical makeup, where they may have oxygen, nitrogen, they have a solar, within their system, there could be water, plant forms.
Yeah. So this really ties into the type of research that I do. So stars and planets throughout our galaxy form from pretty much the same stuff, right? So if they form through the same processes, which is what my research is really trying to understand, with that blob, if they all kind of form through the same processes, then you would expect that the resulting planet would have similar conditions to other similar mass planets in the solar, in the galaxy. One of the things, though, it's going to be important is the proximity of the planet to the host star, like how close it is. If it's too close, the surface of the planet might be too hot. If it's too far away, the surface of the planet might be too cool for life. So there's this notion that you got this Goldilocks zone where the planet has to be kind of in the right distance from its parent star, so its surface temperature is close enough to what we find here on Earth, so you'll find water in all of its phases. And we think liquid water is really important.
Yeah, as soon enough they're going to learn about gravitational forces and but they're not quite there yet. So, there's a lot happening. With this, you use a unique method. You developed a video game, and you use that in parallel with your textbook. Is this something that students in the middle and high school levels could eventually use to continue to learn about astronomy?
I think it would be an excellent teaching tool, and I have been working with the book publishers, so it's just not my game. They kind of own it and sell it. That's kind of like the backside of that. But I would love for high school students and even middle school students to be able to play the game, because I think they could learn a lot of astronomy just by playing the game. Not really even having a class that's associated with it, but it's intended to teach them some astronomy and basic physical concepts just through play, right? Just through gameplay. They shouldn't really need any external lessons or anything in addition to.
And the video game is called The Cosmos?
It's At Play in the Cosmos.
At Play in the Cosmos. Okay.
Yeah. At Play in the Cosmos. You are the captain of a ship, and you eventually have to save the galaxy.
All right. listen, play and learning usually are the most successful combination there is. So that's, and it is also would inspire our students as well. Um, I would imagine within your research, um, there are a lot of instances where you hit a brick wall and you have to go in a different direction and you have to continue to work with your colleagues, and, test different hypotheses and all those kind of things. Um, how do you persevere those things? How do you stay driven with this passion, um, to discover maybe, hopefully, a new planet?
Yeah, well, I think partnerships and collaborations are extremely important uh, in the field of astronomy, in the field of any sciences now. No one's publishing their research, and that's pretty much what we aim to do, right? We do this, we find these exoplanets, and then we have to let the world know about it, right? And so we write articles that announce these discoveries. Um, Nobody announces discoveries on their own anymore.
Right.
Science is a completely collaborative endeavor, right? We do this together. You do it in groups, and if somebody can't figure out a problem, then you get together with your group and you solve the problem as a group. And it's one of the things that I think when I was in middle school or high school, I guess I felt like it was all my responsibility, that I had to do all this on my own, that I needed to solve these problems completely on my own. When in reality, once I got into the scientific community, it's not like that at all. It's definitely a collective project.
Yeah, it's funny because, uh, not only was I a former physics teacher, I was a middle school principal and a high school principal, and we did a lot. We tried really hard to do a lot of project-based learning, um, and have students work collaboratively and each share and use their individual skills to solve problems. Um, and the funny thing is, a lot of kids didn't like doing that because they had the same mindset, like, I got to do this. This is my own. Um, but in reality, the essential skills of networking and teamwork and collaboration, that is what the world is. And it's not just the scientific community, but if we're going to make progress, those are the essential skills that we have to have.
Yeah, and I think the thing that complicates stuff, even for us at the collegiate level, is grades, right? Is that, you assign grades and students really feel that individual ownership of that grade, and having them work in a group makes that more complicated.
Right, absolutely.
So I think that's one of the things we run up against with that.
I'm sure many of our students would be glad if we just got rid of grades and said, let's learn and fun and use video games. I see a lot of kids shaking their head. I don't want to get on my soapbox, but I do think grades are an antiquated system. But that's for another webinar at some point in time. So we have some questions, but we've talked about potential planets similar to Earth. So the scientific community, do they believe there are other life forms out there?
So I'm going to say this as myself and what I think, but I don't think I'm unique in believing that there either is intelligent life out there now, or there has been intelligent life in the past, or there will be intelligent life in the future. The fact that there are planets orbiting nearly all the stars in our galaxy just means that there's too much opportunity, right, for life to have sprung up on another planet. So I can't imagine the universe in which we are it, right? If we are it means that we are extremely special, more special than I can possibly imagine, actually. So there must be life out there.
Yeah, it reminds me of a movie that you and I had discussed before we got on. The kids, many of the students wouldn't know this, and I bet you some of the teachers would. It was called Contact, and one of the quotes in the movie was, it'd be an awful waste of space if there wasn't anything else out there. So, kids, if you're looking for an old movie to watch this weekend, Contact. But anyway, so we do have some questions from our students. And one of the questions, this came up in the last session, we didn't get a chance to answer it. Do you believe you've ever seen a UFO in your research?
No, no. I think we've come up with reasonable explanations that don't include UFOs for just about everything we've seen.
Okay, and what would some of those things be? Natural phenomenon or uh,
Yeah, so for me, I'm typically looking at such a small piece of the sky associated with either just one star or maybe a one stellar system that has multiple stars in it. Um, I'm really limiting my my window onto the universe so much that I'm not really going to see a UFO if it happens to be
right?
flying by at the same time I'm observing. So one, there's that limitation that I probably just don't set myself up to be able to detect something like that. But I'm pretty skeptical about UFOs and aliens actually having made it here, um, because I feel like the fact that we talk about them and the evidence that they exist and the fact that they may have crashed in the desert just does not square with the technological sophistication that they would have needed to have had to have gotten here in the first place, right? So I don't think we necessarily have evidence because if they can make it here, they can make it such that we don't know that they are here. And so I don't
Sure.
necessarily buy that we have evidence that supports that there are aliens among us.
So another student here, Julia, what is the most unusual thing you have seen in the sky?
Oh man, we saw. I, I was in Rio de Janeiro for a conference, and I was on the roof of this building, and we were with a bunch of astronomers. Actually, maybe there's two things, both associated with conferences, and there were these lights that kept like floating up and then traveling over like the water because Rio is right in Brazil is right on the ocean, and none of us knew exactly what those lights were. So for us, I guess they were kind of unidentified, but I'm sure there was a very reasonable explanation for them. The other coolest thing that I saw, I was in Germany for a conference, and I came out of dinner with this. Really, I was having dinner with a whole bunch of Italian astronomers that night. We came out of this restaurant, and the sky was red, and it was kind of foggy, and everything was red. And we kind of stared at each other and was like, "What is going on?" And it turned out that was the aurora. It was a
Oh,
night really active aurora, and of course, uh, me being from where I'm from too far south to have ever seen the aurora before. Italy being where Italy is, all the Italian astronomers had never seen the aurora before, so we had to look at each other and be like, "Whoa!" I think we're all seeing the aurora for the first time in our lives.
can you explain to the students what the aurora is?
Uh, in yeah, in like a minute.
In simplistic terms, with the bending of light rays, and it,
Yeah, well, so the sun, like most stars, spits out material, and some of that material is charged. Or actually, most all of that material is charged particles. Hopefully, I've heard about charges like electrons and protons. So these are the types of particles that are streaming through space, coming at the Earth. You all may know that the Earth has like a magnetic field around it, really similar to like one of those little magnets you may have played with in a class that takes the iron filings or whatever and sets them up into like a really interesting um, geometry. So what happens is that you have the Earth sitting out here in space. It has this magnetic field that encompasses it. These charged particles come in and they actually interact with the magnetic field. That's the whole idea between the charges and magnetic fields. They are at a physical level really interrelated, let's say. So the charged particles come in, they see the magnetic field, and they interact and they travel along the structure of this magnetic field towards our poles where the magnetic field is actually attached to the Earth. And so that's why you see aurora lights associated with either the North Pole of the Earth or the South Pole of the Earth. And so those charged particles come in and they smash into stuff that's in the upper atmosphere of the Earth, and it causes that stuff to glow. And that glow is what we notice as the aurora. And so that glows typically reddish or greenish based upon whatever the composition of the atoms are in the atmosphere that are producing the light that makes the aurora.
that's a really cool thing for our kids to look up. It just Google pictures, and it's beautiful. and as you take physics in high school, you'll learn more about that. We do have a couple more questions. I know we only have a few minutes here. Well, I think we already covered this one. Julie had talked about the myth of where humans came from Mars. So I think we've kind of already covered that. Do we have any other questions for our students? Well, with only a couple minutes to go, it looks like a lot of kids are heading off to their next class, Dr. Bary. I would encourage all of our students to continue to do a little research on your own. In our last session, you talked about resources where kids could find sites. The NASA site is a great site just to go and look at. If you want to just see pictures, where would the kids be able to go and just find pictures?
Well, daily, like if you want to sign up for the astronomy picture of the day, or just bookmark it in your browser, every day there's a new picture and a description that's written by, I think, professional astronomers that tells you about that object. And those tend to be some of the best pictures we have, right? And often they'll be up to date with some of the most recent discoveries we've made too.
Okay.
That's a good one. And then if they want to really get into it, they could subscribe to the Astronomy Magazine or Sky and Telescope and get a monthly periodical about astronomy.
Okay, awesome. For students who will think of something after this, if you want to email me or Ms. Carson, and we'll get your questions to Dr. Bary, and we'll try to get some of those answers if you have additional questions. But for us at CFES, this has been a great experience, a lot of great student participation. Thank you for all signing in, and Dr. Bary, thank you so much for sharing your wisdom and your insights and your stories with our students at CFES.
Chris, thanks for having me. This is always a lot of fun. Appreciate it.
Okay. All right, everybody. Have a wonderful weekend. Stay warm. It's about -5 up here in Plattsburgh.
Yeah, I think we might be at 2.
Okay.
Here in Hamilton.
Thank you. Well, we didn't have any students screaming that time. So overall, I really appreciate it. I think this was great turnout. Claire, do you think most of the kids were our Wilkesboro team, or was it, because I saw
the
kids
second
coming in from
session
other
was
schools
mostly
that I know.
Wilkesboro.
Okay. I know Mike had some kids there.
Yeah.
As he was on from Malone, and I saw a couple of students that I worked with at Sable Valley, so that was nice.
Where are those places? Claire, where are you?
I'm in Essex right now, and so Willsboro is like the town next door, I guess. So I'm looking at Lake Champlain.
Yeah.
So are you familiar with Plattsburgh, Jeff?
No. I know that I recognize the name, but I have not been.
From Utica, Hamilton area, a diagonal directly northeast, right on the New York State border.